lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you'd like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and there's also a PayPal link in the info box below the video. If you'd like to join the panel, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcomed back on the next stream. Please also share the show. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel, or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by Zinda, The Plain Truth, Sleeping Warrior, Jose, Event Horizon, Arwin, Chris, who's this? Earth Flattener, I think it is, and the Flat Earth something. Good to have you all.
Hi.
Good afternoon.
Hello.
Hello.
I've got a question. You know, molecules when they're heated and they expand, and they move through the atmosphere. So wouldn't that immediately say that gravity doesn't? There's no gravity. Just the fact that a molecule can expand based on heat and move through the atmosphere independently. There's no directional force to it.
That's right. It's a separate effect. That's entropy.
Exactly. So why is gravity selective?
I don't know why. It just
Gravity
is.
is very selective, isn't it?
It's bollocks.
It isn't selective.
So here's the thing: if it's so
It's
selective,
directional.
if it's so selective, like for the majority of people, they drop something, right? This is gravity. They drop something. Now, a molecule at its basis is designed to find its place within the atmosphere. That's what a molecule does. So if you have a compound and you have a molecule, well, we're made of both, right? So here's the thing. If the common denominator is that a molecule has to find its place, and there's evidence of a molecule expanding, thereby disproving gravity, why do we assume there's gravity? What is the underlying factor that we're assuming gravity exists?
It has nothing to do with that. That is entropy, and it only applies to gas state.
No, it's molecules.
No. Oh, really? So really?
Everything is made of a molecule, or everything. Yes, molecules are rocks. Two atoms together makes molecules. So anyway, we're all molecules.
So take a vacuum chamber. Put a rock in it.
Answering my question.
Then open up to another vacuum chamber.
It's not going to answer my question, Arwin. Answer my question. Explain to me why it's so selective.
I don't know. It's an inherent property of gaseous matter. And there is theory about this, which I think is pretty reasonable, and that is that solid matter, simply the ties of the matter, the inner ties, prevent it from, basically spreading out and flowing off with the rest of the matter that is subjected to entropy, which is gas.
So what did you just say? What did you just say, Aaron? What was your answer?
What?
What did you just say?
I said that solid matter, the ties between the bonds between the molecules and solid matter are so strong that it's not gonna normally be subjected to entropy, which gaseous matter does.
Okay, and where's your evidence for that?
Everything's subject to entropy.
That's very easy to demonstrate.
Demonstrate it. Okay, go ahead. Keep going.
Right. Okay. So you take a vacuum chamber and you take a chamber that's not evacuated. You make a port, put a rock in the gas chamber, and then you open up the hatch to the vacuum chamber. Well, all this air is going to be sucked up immediately, find its equilibrium within the.
That's right. So the molecules get moved by a suction force, right? By a suction force.
Thank you. Thank you for letting me finish. Thank you.
But you're creating a suction
force.
The
rock is going to stay in place. It's not going to move while the air, which is a gas, is going to be sucked off immediately. because of entropy. So solid matter is not subjected to entropy unless it is so small it's like dust riding the wind. Because dust can still blow up if the turbulence of the gas leaving is strong enough.
And then this proves
only very fine particles that can be carried by gas.
And this is telling yourself that you can prove gravity selective based on this.
No. Gravity is not selective.
Gravity so selective.
No, gravity is not selective. All I'm saying is that entropy only is with gaseous matter. And why? Because solid matter is not subjected to entropy because it's solid.
Selective. And you're telling me that gravity doesn't affect entropy because it's a selective attribute to.
No, I'm telling you that entropy is a lot stronger.
Oh, it's a lot
It's
stronger.
one of the most powerful inherent forces.
Okay, so
that
here's
can
the thing.
take
Here's the
place.
thing. You can't demonstrate gravity on water. The only thing you can do is say that it falls to the ground. It falls to the ground like every other a molecule or compound.
That's right. That's why I said gas and not liquid.
You can't take water and make it curve over center of mass. So once again, gravity is
guess
selective.
what? Water is not subjected to entropy.
Selective again to water and to entropy. Because you're
water
telling me
is not subjected to entropy.
Water is either stronger than gravity because you don't see it curving in large quantities. So it's either stronger than gravity, just like entropy is.
Water is not subjected to the same effect, PSI. It's directional. There is pressure there. Water pressure. It's a different thing. It's not entropy.
We never see it curve, Arwen.
What?
We never see water in large scale curve. Why is that?
Oh, wait, hold on.
Because the Earth is flat. What do you think?
So I'm asking you why entropy is stronger and water is stronger than gravity. We never see the effects of gravity on water in large scale. It's not a nonsensical question.
Yeah, it is. It's totally nonsensical.
We never see large quantities of water curving. Do you understand what the question is?
Yeah, I know.
Okay, so where's gravity? It's absent?
No. It's
So
still
why is it selective on entropy and why is it selective on
all matter is subjected to gravity.
Shout out to SX0 for the super chat. Says good morning, guys. Good morning to you too.
It sticks down. It stays down. So yeah, mass. All mass is affected by gravity.
Explain the molecule of water is denser than the molecule of the air.
That's true.
So that molecule will find its place within its chamber. We are living in a density chamber. Earth is pressurized, and the acting pressure is 14.7 kilopascals. That's the only measurable acting force. Now we have a barometer.
No, it's not.
That's our active pressure force that's surrounding us 24/7. That's it. It's air pressure. We have a barometer. We have a barometer that will indicate lower high pressure area. There is no measurement that gravity increases or decreases based on high and low pressure. If our atmosphere is held down by gravity, why is gravity being selective in a barometer setting?
It's not selective at all.
Of course it is.
No, it's not.
Yes, it is.
No, it's not.
No, hold on. Stop. Both of you stop. Hold on. Stop. Arwen, hold on. So this was conceded by you earlier, Arwen. Your answer being, I don't know why it's selective. Now it's
yes,
no,
it
it's
was,
not.
Arwen.
No, that's not what I said.
Yeah, it is.
Yes, you did.
Yeah, it is.
Yes, you did.
You really did.
Gravity? What are you
Arwen,
talking about? That was entropy. I talked about entropy. Entropy only works on gas.
Arwen, please listen to me, please. Earlier, when this discussion first began, and the speaker said, "Why is gravity selective?" You said, "I don't know."
Right. Well, that's not an admission, really. That's just saying I was probably, I don't even remember this. I will look it back. I was probably saying I have no idea what you're talking about.
Now you know.
So I'm not conceding that at all. Gravity is not selective. Universal, that's the thing about it.
Earlier you don't know. Did you research throughout the show and now you know?
All mass is subjective. So yeah, sorry to disappoint you with that false hope there, but
we don't have time for a meeting with the Arwinian Society.
You disappoint me, but if anything, it just shows the weakness. So gravity is a catch-all phrase. Molecules in themselves have their place inside a density chamber. We see evidence of that. We can see that. We can measure that. So why do we need something selective to understand our world when we understand at a
Not
basis.
selective.
You already said it was.
No, I said that's not what I said. And even if you interpret it as such, I take that back.
All right.
Because
who's
that's
this-
not what I said.
So-
Who's the
so you-
speaker?
you
Hold on.
take it back.
Hold
So
on real
explain
quick.
to me
Hold on real quick. Who's the speaker?
Flat Earth data.
Okay, flat Earth data. Can you start over again and do your molecule question, and let's just go back to that. Explain your molecule scenario and ask him the question.
So molecules, when they're heated, they expand, negating gravity, and they float independently to find their place again within the atmosphere, within the ether, correct?
They're pushed there by the more dense.
Okay, so they're pushed there, but you don't understand. They expand within the atmosphere that's compressed, and
That's the
thereby
first thing that happens.
giving its own independent directional. It has independent thought. Let's say it goes wherever it wants to go.
What are you gonna
within the
enemy
atmosphere?
matter again, series?
Okay, we are compounds and molecules ourselves. We ourselves find a place. A rock is a compound and a molecule. It will find its place within a density chamber. Okay, why is gravity selective in this matter when
It's
it comes
not
to molecules?
selective.
Yes, it is.
No, it's not.
Yep.
No, it's not.
Then explain to me why water in the ground doesn't curve and why there's clouds above.
Because it has
The
nothing to do with
process-
freaking
the process
curving.
of solid to a gas negates gravity.
You're making no sense. This freaking water curvy shit. I don't believe that. Water is flat. There's nothing to do with water curving.
Reality. We're molecules and compounds. We live inside a density chamber. We know at the simplest level that a molecule has to find its place within that chamber. That's bottom line. There's no gravity pushing it. We have air pressure around us pushing on the molecules and compounds. We can measure that. Okay? We can see how entropy is in between a cloud and the atmosphere. We can see how a gas expands, negating anything to do with gravity. If we can totally negate the control of gravity, then why do we assume it exists when we don't see any evidence on it in water in large scale? We don't see any curving of water around the center of mass, which gravity supposedly does.
No,
we
it
don't
doesn't.
see any evidence of it. We can't
It
measure
doesn't do that. Stop putting that kind of shit in my mouth, okay?
No, stop.
Your
Hold on,
gravitational pull crap
Arwen.
to yourself,
Arwen,
please.
Arwen, this is the problem. So you have a whole bunch of people who are fighting against a standard rhetoric. Now, when you say don't put words in my mouth, you're using the words of the standard rhetoric. So the assumption, especially when there's ballers fighting the same argument on the panel, is going to be that you agree with this. Now, the fact that you don't is going to require a disclaimer every single time you get into this conversation about quote-unquote gravity.
Yeah, and that's what I'm doing right now. If there's any misconstruencies, I will clear them up.
Did you understand what Nathan just said, Gina? Oh,
Yes, I do.
okay.
All
Really
right, so
doesn't sound like
just,
you do, man.
I just have a quick question for Arwen. Arwen, did you say that water isn't subjected to entropy?
Well, not in the all directional way, like gas is. It's directional. It goes to the side only. It doesn't really go up.
Okay, so if you have gas pressure in a container and then you open that container, you would say entropy steps in and that gas finds its equilibrium. Yes.
Instantly, yes. It's
okay.
Very
So then, if
powerful,
you
very quick.
Okay, so then if you have water in a container and you remove the boundaries, isn't that the same thing?
No, it doesn't go in all directions.
Water does not go in all directions. Well,
What, if you
go
had it in
up.
a back?
It's
Sorry.
Boundaries, it will flow to the side.
Hold on. Let's just get
But
clarity.
Inwards.
Sorry, are you
Doesn't
saying
go up.
in a vacuum? Is that what you're saying, Travis?
I'm just trying to understand because in my mind, conceptually, when water gets spilled out, that's entropy, even though it's not up.
Yeah, everything
It's out.
suffers. The effects of entropy are all-encompassing.
All directions. PSI.
Everything is suffering the effects of entropy, Arwen. Everything.
No. All gas.
Not just gas, no.
Yeah, oh really? So find me the PSI reading on rock and water,
Sorry,
please.
it seems like you don't understand what entropy is.
It's a heat gradient. Go from hot
So
to
it's
cold.
not
That's
PSI,
gas, is
then,
it?
is it?
PSI
Is
is pounds per square inch. That's a pressure
Yeah, right. That's
value.
like
That's-
how
that's
you
not-
measure
That's not
it,
entropy.
right?
That's air pressure, though.
That's
Got
not
nothing to do with
entropy.
That's the effect, pushing in all directions, expanding until you can't, and then when it's settled, that is when you get the psi. It's because of entropy.
And what's entropy? Just tell us what entropy is.
Entropy is the need for molecules that have the maneuvering room to find an equilibrium space between them, basically. So rapidly expand, they will push everything aside in an equal fashion until equilibrium between spaces in the total container between each molecule has basically been found.
And that's driven by
Right, well, there's a bit of rumpusing. Shout out to Howard Massicott. Hope I've said that right. Thank you very much for the super chat. Really appreciate it.
Arwen, that's driven by its natural state of density. That's where a molecule finds its space, is driven by its natural density state. Therefore,
I believe that. Yeah, I think that.
And the egg in the water is the egg in the water is the exact same thing when it comes to neutral buoyancy. 100% the same thing. At a molecular level, that's exactly what it does. It doesn't change. The concept doesn't change.
No.
You're trying to change the concept and give it selection. It doesn't have selection. There's no evidence of selection.
Not caused by entropy.
I'm talking about molecular level when it's talking about finding its place due to density. There's no driving force other than the force of density to put it in its place. That's it.
Density is not a force. Density.
Molecular level.
Aspect.
A molecular level.
Molecule. It's
the
not a
object
force.
of the molecule finds its the molecular level. The molecule finds its place. Finds its place due to a density, not to do with anything else. Due to density of the molecular level.
Right.
That's not right. That's a fact.
You're declaring that density is force inherent. Well, good luck proving that.
That's
a fact. See you prove that.
So an egg in water does the exact same thing at a molecular level.
No.
The concept doesn't change.
Horseshit.
It's not bullshit.
Yeah, it is. You're talking total horseshit. Yeah.
Prove me wrong, bud. Prove me wrong.
Oh, really? Why don't you prove your assertion that density is force inherent? Good luck with that.
Prove me wrong, buddy. Come on.
Bring me the proof.
I just challenge
density force inherent.
Correct.
Bladder.
Make that work. Make that work.
Bladder, when you make things, when you put things in free fall, you can say you remove something, like when you put something in a water rocket that one can build, and at some point there is a state people call 0G. I just call it like this, but you don't have to accept the G in it. So at this state, the liquids like oil and water start to interact with each other again and start to be all over the place. So they have a different density, but yet they still mix with mix with each other.
About hydrogen? You want to talk about hydrogen bonding and how there's a positive and a positive and a negative within the cell itself, or within the compound of the water?
No, I'm not talking about this. I'm talking about oil and water mixing in itself when they reach this 0G state.
No, that's not correct. You're talking about free fall. You're talking about free fall.
Okay, so
hold on. Let's just get clarity from Zinda. You are talking about when a plane descends hurtling towards the ground, correct?
Yeah, for example.
So it's not in 0G, it's in free fall. So what you're saying is liquids don't settle when they're falling, is essentially what you're saying, Zinda.
Yeah, but they still have a different density.
Wow, what a revelation. So if I throw liquid out of my window, let's just get my point in. If I throw liquid out... Who's rumpusing me? If I throw liquid out of... If I throw liquid out of my window, it won't settle while it's falling through the air. That's incredible, Zinda. Wow, what a revelation.
Yeah, thank you very much.
That's an amusing laugh, a bit like Make Four's laugh.
Yeah.
Yeah. So when someone's told you, probably on TV, that these liquids, when in quote-unquote... Don't rumpus me.
I don't watch TV.
Whatever, wherever you've got this nonsense that we should have settling liquids while they are in free fall is, what's the word? Nonsense.
Yeah, same as gravity is selective. It kind of seems nonsensical to me.
Agreed.
Well,
So-
the moon's really selective about the gravity.
when you-
That's a really good example.
And like the selective part. So why is density selective to up and down and not left to right? This is also something I don't really understand. Why up and down?
You mean up and down are relative terms?
Yeah. So left
relative.
is left to right, up and down, and it's yet only can see up and down and not left to right.
But
When
up
have
and
you
down
ever
and-
fallen
hold on,
left?
these
When
are
have you ever
all
fallen left?
they're all relative terms.
Yeah.
You've got to have a relative. You've got to have a starting point in order to establish what's going up and what's going down.
To
Yeah.
be fair, I've fallen left once or twice in my time.
Yeah, hold on. Yeah, maybe, but if you release a helium balloon and it goes past an airplane that's on a fixed height, the plane is going down to the balloon. From the reference frame of the balloon, that plane is going down. From the reference of the ground, it's staying the same height.
Mm-hmm.
Well,
yeah, it's relative, I know.
Right. So when you say, well, which direction? Why is it always down? What do you mean always down? It's not always down. Depends on the medium and the material in terms of what direction it's going to go, and it's relative to its starting point.
In compared to the highest mass of the Earth, let's say it like this. This is for me down. But I know it's relative. Someone who like is on top, like switches from top to bottom with the head, can say, all right, the other person is up, the other person is down, the other person is left, the other person is right. Everything is relative. I know, but when I look at density, I still can see two directions that matter, like
They're
up
not
and
direction.
down. What are they?
Say again.
The relative positions.
Yeah, relative positions.
We describe them as directions just so that you and I understand what we're talking about. Directions don't exist for animals and stuff like that. It's relative to them. Don't exist for gases.
Yeah, just to simplify things when I say direction.
Yeah.
So
but it depends it depends on what you are and where you are. So if you're a fish, you know, up, down, left, right, it means nothing. You know. They'll vary. Well, yeah, Anthony said it was a swim, or slightly different. I thought it was a swim bladder, but it's based on its pressure. So it doesn't know up or down. It just knows, you know, it doesn't even know what it's doing, I'd assume. It's just biological. It just does it if it wants to go over there. You know what I mean?
Yeah. Yeah, you're right. So...
Say hello, Unorthodox.
Hello, I'm here.
Good to have you.
Thank you.
All right.
Can I just clear something up with Orthodox? So I've been accused of racism by calling Unorthodox a hillbilly. So someone compared it to calling a black man a nigger, and I said, really? Is calling somebody a hillbilly as severe as that? If so, I never want to call Unorthodox a hillbilly again, if that's the case.
I'll call him a hillbilly if you think I'm racist for it. Tough shit.
Well, regardless, I just want to know if that's the case or not, and Unorthodox would probably have the answer.
No, it's no different.
No, that's not similar to calling somebody...
Oh, I can't hear Unorthodox. Say again. Say again.
No, that's not equivalent. Calling somebody a hillbilly versus calling somebody N-I-G-G-R-E-R. Now, N-I-G-G-A isn't as bad. N-I-G-G-E-R, that's pretty rough. But no, calling me a hillbilly, no, that doesn't bother me.
I love it when other people get offended for you. It's really nice.
Yeah. Oh, that's how it works today. Other people get offended for everybody.
Okay, I just didn't know how severe a derogatory term it was. Now I know. Thank you.
No,
so is the answer to the question, it's not that severe?
No.
No, it's not that severe.
Who was it that called you a racist?
I was just someone in comments.
Give it a couple of years and maybe it will be.
Yes, awesome. Well said.
Everybody got to love a hillbilly though, right?
Retard's pretty bad, Nathan.
Yeah, retard. You're not supposed to say retard. That's
why not?
People.
What's wrong with
or
retard?
midget. I don't know. It's just there's like a list of words that were okay 5 years ago that you're not supposed to say anymore. Midget's one of them. Retard's one of them.
Really?
Cunt's a big one in the U.S. I know you guys say that in Britain all the time, but like if you say
it's
cunt
harsh
in the
here
US,
too.
people freak out.
Global
It's
will be
the
one
same here.
thing.
Same here with that word.
Yeah.
Like in 3,000 years or not even. the rate this movement is gaining people, I don't think it is enough to. For me, when I'm still alive, it's not enough to make a big difference on the world.
Whatever.
But it's just a stupid prediction.
Whatever, bloody foreigner.
So
Is Nummy Num on the panel?
No, unfortunately not. Why?
Yeah, me and him were having a conversation yesterday. It was maybe about 12:30 my time, and I randomly refreshed the Google Hangout, and Zender and Nummy Num were talking, and me and Nummy Num were talking about the inverse square law and the barometric pressure equation, and he was saying that they were extremely different from each other. So I made a nice, neat little graph for him where I graphed both of them, and I wanted to show how similar they look.
You're welcome to
But I'm
present
not
it.
really.
It's like the
You're welcome to
equation for
present it if you want to.
centrifugal force and
I know
the
he's not
equation
here,
for
but that happens
centripetal.
all the time. So if you want to present it anyway, you're welcome to.
I'm not really sure how to get it to you. I'm on mobile right now. I'm trying to think of how I could possibly get it to you. Let me see if I can work this out.
If you have the file, you can just put it in the chat, and then someone else can bring it up.
Oh, really? Okay.
do you have access to the chat on mobile?
Should have.
That's why I don't really use the mobile that much, so I'm not really sure how to access chat without cutting you off. I think. Okay, here it is.
Oh, perfect.
Let me see. Okay, so I can send an image, huh? Okay. Okay, there we go. I just sent it. I sent it in chat.
Might have gone into the back chat, so is anybody willing to go into the back chat and dig it out? Clearly not.
Sleeping water
Yeah.
got you.
Yeah, he was saying the inverse square law. You know, the gravity, right? The gravity has the inverse square law. You know, it's proportional to the distance divided by r squared, right? So this is a graph where I look at the barometric pressure equation versus the inverse square law, and show that they're not perfectly identical because you have other forces at play here, like collisions between atoms, but they're very similar. They look very similar. So I would say that's a pretty good piece of evidence for gravity right there.
Have you seen the similarities between the formula for centrifugal force and the formula for centripetal force? They're the same.
They're the same. One's the momentum of the material, and then the other is looking at the the object that wants to fly away, right?
Yeah, but
So
they're opposing forces officially.
Yeah, they're exactly.
So they shouldn't have the same maths for them, right?
No, not necessarily. They should. They're equal and opposite, right?
Yeah, but they're not the same though. The maths should be opposing. There should be a plus instead of a minus, or a division instead of a multiplication.
There is a plus and a minus associated with either one.
No, the equations are the same though. You said it yourself a minute ago.
Yeah, the equations are the same, but you have to set them up in a coordinate system, and whenever you set them up in a coordinate system and look at them within that coordinate system, you get a negative sign in front of one of them.
I don't think that's true. I think they're both identical.
Well, if they were identical, then they'd be in the same direction.
That's my point. They are in the same direction because they're identical.
I think what he's trying to say to you, Anthony, is that it's only in application that you would have them opposing each other, and therefore you would need different descriptions for one over the other, even though the mathematics is identical. I think that am I paraphrasing that correctly?
Yeah, that's right. You have to, you can't just look at the equation in isolation. You have to look at the equation when it's applied to the situation.
Right, but the problem that we have here is the same thing with Arwen, where Arwen said that he doesn't know why gravity is selective, because when Anthony said what he said, or unorthodox, you conceded, you agreed straight away, and now you're making qualifications. So the problem is either you weren't listening and you agreed to something you didn't listen to, or I don't even know what else the other option is. So the problem is that initially, when Anthony said what he said, you said, "Yup."
Yeah, I don't see a problem with that.
Well, it means that you were either wrong to agree initially, or
No, the equations are the same, but you have to apply them in proper context.
Well, how can they be the same when they're opposing forces?
Because they're equal and opposite. You hear about that all the time,
Yeah, but
right?
they
Equal
can't
and
be the
opposite.
same, though, right?
Yes, they can. Equal and opposite. You hear about this all the time, right? In physics, every reaction has a equal and opposite reaction. That's exactly what's happening here.
Okay, my phone's ringing, so excuse me.
Is this the case that you are given a certain set of data and you apply it either without previous knowledge or with a knowledge that have been presented to you and taught to you before?
Say that
Because
one more
if you
time. I'm
didn't know,
sorry.
if you didn't know the official explanation and you are just presented with this set of data, you wouldn't know it were opposite forces. You would say, "Oh, these are identical, so they will go just as is."
Well, I mean, if they were presented within the proper context, like looking at a body that's spinning around an axis, you could easily tell. One is like if you have a string and I'm swinging the string around and there's a lead weight on the end of the string, right? The centripetal force is pulling the lead weight toward me, keeping it in a circular path, and then the centrifugal force is the momentum of the lead weight trying to escape. They're equal and opposite.
No, there is no force pulling the lead weight towards your hand.
I'm talking about if you have a string on it. Yes, there is the force that's carried through the string.
No, there's not. No, there's not.
They have to cancel each other out. Otherwise, this would be
It's not before.
otherwise it wouldn't stick to the string if they don't cancel each other out.
The only force that exists when you're operating a sling is the weight of the rock against the pocket of the sling, which is centrifugal force. That's the only force that exists. There's no such thing as centripetal force. There is no force pulling that rock toward your hand.
Yeah.
Yeah, there is. You can measure it. You could easily measure that, and you can feel it in your hand, right? If you're
What you're
if you're
feeling,
swinging
no,
a
what
sling,
You're feeling it being pulled back in your hand. You're feeling it going.
You're feeling the inertia of the movement of the rock being propelled in a circular motion. So you're feeling that weight. You're making that weight. The faster you swing it, the more inertia you're going to get towards an outward momentum. That's the only force you're going to feel is an outward momentum due to this the velocity of the rotation. There's nothing that's going to be coming towards you. It's going to be an outward force. It's the only thing that's ever created.
If there was only one outward force, the rock would fly away.
No, you have a string attached to it. You have a string
being held there.
That's right. You have a solid object holding this. Okay. Now a string has some flexibility to it. Some. You know what I mean? The material itself has some fatigue in it when it's being pulled on. But other than that, the only force that's being created is an outwardly force due to velocity of your rotation of your hand, which you are creating. There's nothing inward.
If you stop spinning, that thing isn't going to come flying back towards you, is it? You're not cancelling out a force. It's just one force involved.
It's due to the rotation. The rotation is causing the forces. I could set this up. This is an example I was thinking about doing. I could set this up and show you guys that this is true. All you need is like a rotating, like a little cake stand that rotates, and you could show that both of these are true. I mean, this is
I don't
well
know why
known.
you have to. You don't have to set
physics.
unorthodox. You don't have to set any.
Go ahead.
Unorthodox. You don't have to set anything up. There are gravitrons. There are slings. There are yo-yos. Whatever. I had a half-hour discussion with a physics professor in New Jersey at one of the campaigns with Maryland Spirit Level. Half an hour. This guy could not understand this concept. He had to have the rock wanting to come back toward my hand.
If it was,
couldn't
if it didn't
understand
want
it.
to come back towards your hand, it would fly away from your hand.
It won't fly away because it's constrained by the pocket of the sling.
So a bucket of water,
Yes,
the water's in the bottom of the
that's
bucket.
what's causing the force, right? It's contained in the pocket of the sling, which is being pushed outward.
What's causing the force is the rotation of the spin, not the sling, not the pocket of the sling. It's the rotation. It's the momentum created in the rotation. It's being confined by the sling. The motion is not allowed to escape. It's being held back. So thereby it's creating an inertia. If it wasn't held back, there'd be no inertia. It'd be flung off. But the fact that you have a barrier, you guys in barriers, man, you can't like wrap your head around the barrier. Like, how do you expect to experience any inertia?
Yeah, I mean, this is pretty simple, guys. I'm kind of surprised.
I don't know. It's pretty simple. That's
really simple. Don't understand. You don't get it.
Right. So what happens when you release so you have a sling?
You let the inertia go. You build up the energy. You let the energy go. You do.
Yeah, actually, what happens is the rock comes flying back and hits you in the face. That's what happens.
So this could be related back to a tug of war, right? On a tug of war, you have
a swing.
Sides.
You are propelling an object out. You want to let an object go. That's the purpose of a sling, right? A tug of war is a purpose for one side to win over another side, right?
A tug of war is two forces pulling on a rope, right? One man on one end, another guy on the other end. They're pulling the rope.
And a sling is one force.
That's exactly what's going on here. The same exact thing.
One force with the sling, two forces with the tug of war.
So what's the string? Not a force?
The string is carrying the force.
Carrying the force. So it's a rigid object that has the inertia, the contained inertia in it, and it's being delivered to the end to the rock. So it's an inertia delivery device is what the string is called, in my opinion. It's delivering the energy down to the rock. Or the sling itself is pulling back the energy within the arms itself, delivering the energy to the rock.
But you guys have a problem with like every part of physics. This is absolutely absurd. This is
no, it makes sense.
We have a problem with illogical physics. We have a problem with physics that aren't real. Yeah, that's right.
I can show you this is real in my living room in like 30 minutes.
Force. There's no inward force on a rock. There's zero inward force on a rock.
Force, the rock wouldn't stay there. The rock would move. If there was only an outward force, the rock would be moving outward.
The energy is built up. If we're talking about a sling, we're building energy up into the elasticity of the arm, the whatever the rubber band is. We're building energy there into it, right? The inertia is going to be built up within the rubber bands. We're going to transfer that inertia into the rock. The rock is going to take the inertia because it's not constrained. It's going to fly off. When you have a string attached to a rock, you now have that string delivering the inertia towards the end because we're sending energy.
Yes.
Right? We're sending energy to this rock and we're confining the rock. Therefore, there's inertia built into the rock.
Yes, exactly. You're confining the rock.
There's only one force being applied outwardly. That's it. There's no force being applied inwardly. There's nothing to be measured. There's an outwardly inertia. That's all there is.
It would. I mean, this is like physics 101. If the rock was,
it's actually evidence 101.
Something to travel.
That's right.
In a
it's your
path,
physics 101.
Hold on. Let
an
Orthodox respond.
It's nonsense, Orthodox.
Let me finish my explanation. If the rope wasn't pulling the rock backward, the rock would be releasing.
The rope is not
moving forward. It's simple as that.
The rope is not pulling anything.
Then why isn't the rock going forward?
Because it's
the rope.
Hold on, there's a word you're missing. It's resistance. It's resisting. Sorry, Event Horizon. Can you put yourself on mute?
Right, you can.
Event
If
Horizon,
you have a
can you
sling
put
in your
yourself on
hand,
mute?
you can feel the force. You can feel the pulling motion of the sling.
Yeah, and
So
there's a resistance.
It wasn't pulling.
There's a
if you weren't
resistance.
pulling
If it's in a
inward
sling,
on the rock, the rock would be flying outward.
No, because there is a...
As soon as you let go of the
you
rock...
just rumpusing.
Or as soon as you
You're not listening, you're just rumpusing.
As soon as you let go of the
Stop
sling,
talking!
you're no longer pulling
Stop
back
talking!
on it.
You keep repeating the same words over and over again while I try and say one word.
On to a new explanation.
Trying to say one word. Resistance.
And?
Yeah, there's a resistance. If you're hurling it round in a sling, the sling is resisting. It's not providing a force back the other way.
Nathan, you're just basically explaining forces in flat Earth friendly
No,
terms.
resistance. It's
Yes,
providing
resistance
not a
via the
force the
force.
other way, a resistance.
Reality
Resistance
bites.
via the force.
Reality bites, doesn't an unorthodox.
I mean,
You know
this
what?
is just
You know
so,
what
this
was
is
amazing?
just so absurd, guys. I mean,
Explain
it's
to
just
me how a
evidenced by the
sling,
fact
how
the
a
rock isn't
barrier,
moving
how a
forward.
barrier. I called it a barrier. Nathan's calling it resistant, which is fine. But how is it a force? How is a barrier or resistance a force towards an object? We know that the rock has.
Because you're accelerating it.
We know how the rock has weight already. So let's say we put the rock in the barrier or in the resistance point. We know that that material is a solid object. We know that it can withstand the weight of the rock, right? We know this already. Okay, so we're going to pull back, create an inertia energy inside the rubber bands, and we're going to release the rock, transfer the energy out, right? There's nothing propelling it inward from an outward trajectory. Explain to me how an inward energy force helps an outwardly force as inertia or the revolving of the centrifugal force, sorry.
There's a balance going on between you spinning the object, which is creating acceleration, right? You're accelerating it in a circle. So it's wanting to fly.
And the
wanting to
string,
fly
focus on the
outward.
string though. The string is holding it there. It's the barrier from release. It's the resistance from release. There's a barrier there.
Let me finish my explanation.
But why are you negating the barrier? The barrier isn't
I'm not negating the barrier. I'm just going to explain. Let me explain it to you, and then you can have a rebuttal, okay?
The resistance is not a force, though, right? You agree. The string is not a force. You agree, right?
Resistance isn't really defined.
The string is not a force. You agree,
We're talking
right?
in scientific terms here. Resistance is used to measure resistance in
I know,
electrical
but the string is what in the math?
He just said it. He just said it.
What's
He
the
said
string?
it. Hold on.
Not
Hold
only
on.
the string.
Hold on. He just said it. So a resistance measures how much resistance is placed on a force. Correct? Unorthodox?
No, that's not.
That's what you just said.
Not scientific.
That's what you just said. That was
way.
what you just said.
No, I'm talking about electrical circuits.
So in an electrical circuit, a resistance is how much it prevents a force, correct?
Resistance is how difficult it is for electricity to travel through an object.
Or how much a ball can travel through a sling, depending on its resistance. If it's a weak sling, it might make it through if it was a weak gauze. But if it's a strong sling, it might not make it through. So it's pretty much the same thing then. It's how resistive the sling is.
You guys are making so little sense, it's impossible for me to
say it again
make
then.
a
If it
rebuttal.
doesn't make sense, I'll repeat it. I'll repeat it. Hold on. Why am I getting rumpused? Please. I've let you argue about it. Can I just get my point in?
Make too much sense.
Oh, gonna get rumpused by him. I've let you waffle on indefinitely. So, we're gonna have two different slings. One's gonna be made of cotton, and one is gonna be made of toilet paper. Now we're gonna start swinging them, and you know what happens pretty quickly, even with a really small rock? The toilet paper tears. Its resistance.
What does that have to do with what
Shut
we're
up!
talking about?
Shut your stupid mouth.
Why
So,
don't you shut your
two
stupid mouth?
slings. One made of toilet paper, one made of
Shut
cotton.
up! Shut your stupid mouth.
Yeah, I'm giving an example. Just because your asshole example decides that what is actually resistance is a force in the opposite direction won't change anything about my example. So we're going to swing a rock around in tissue, and then we're going to swing a rock around in cotton. And you know what's going to happen? One, the one with the greater resistance, or actual tensile strength, but that's irrelevant. The one with the greater resistance will hold on to the rock, whereas the one with a lesser resistance will not. Simple.
Am I unmuted now?
What, while you rumpus? I could see a little level dancing around while I made my example. In other words, for the audience's benefit, he just rumpused every word I just said, so none of the panel got to hear me. Correct? Hands up on the panel who actually got to hear that.
Bits and pieces.
I really
Yeah,
don't
of course.
understand what
Now,
that has to
I'll
do
say
with
it again for the
anything we're
panel's
talking
benefit,
about.
and if you don't let me unorthodox, I will kick you out. So, we have 2 rocks. One is going to be in a sling, one is going to be in a piece of toilet roll, tissue. As you swing it round, the one in the tissue breaks free because the resistive value is less than the cotton. So nothing to do with the force going back on the rock and everything to do with how resistive the sling is.
I really don't understand how that comes into play with what we're talking about here.
Oh my God.
Because I'm saying it's down to resistance, and you can measure whether or not the rock breaks free based on one thing: how resistive the sling is. More resistive, it carries on in a circle as you spin it. Less resistive, it flies off and breaks through whatever's resisting it.
Yeah, I don't understand how that.
Well, then you're thick. Well, then you're stupid.
Is that because you're a hillbilly unorthodox?
Yeah, is that because you're stupid?
No,
it doesn't make any sense.
It doesn't make
It
so.
makes perfect
Hold
sense
on,
unorthodox.
Travis.
How can
Let's
you
take
not understand
Travis.
that?
Hold on.
It's
Let's just take him
perfectly
through.
It doesn't make
Which
any
bit of
sense
it don't you
in terms of
understand?
what we're trying to
What
talk
doesn't
about.
it
on.
make sense about?
Don't rumpus me. Don't.
Because
I
we're
let
talking
you have
about
your conversation with
he's
him.
talking
Come
about
on.
an object
Be
breaking
reasonable.
through toilet paper.
So you don't understand that toilet paper can't resist the spin with a rock inside it, but cotton can? You don't understand that.
No, I'm telling you that's a moot point.
It's not moot. It's
No.
entirely the point. We're saying it's a resistive value. You say you swing a rock around in a sling and it's got a force acting back the other way. And we say, no, it's just a resistance. And you say, nah, it's a force acting the other way. Well, what if we changed the sling? We didn't say what kind of sling. Let's change it to made out of tissue paper. Does it still resist because there's an equal and opposite force as we spin it round? It's the same spin. Oh no, the resistive value of the sling has gone down and it doesn't carry on spinning. It goes out with the force that's applied while you rumpus me, you hillbilly wanker.
If it's resisting at any point in time, it's resisting the rock moving forward. Therefore, there's a force there.
Yeah, so I pick up the sling made of tissue paper and initially it can take the weight of the rock. Then I start to spin it very slowly and very gently and it takes the force of the rock. Then I increase my spin and it stops resisting and it lets loose. We do the exact same thing with cotton and what do you know? It stays in the sling because it has a higher resistive value. Well, that shits all over your argument. That's what, so what?
No, it doesn't at all.
Yeah, it does. It completely demolishes it. We're talking about resistive values, not centripetal forces. Okay? So, yeah, it does. It craps all over your argument. You don't have to like it, but it still craps all over your argument.
What would the force
You haven't
be?
even let me make my argument.
I can answer that. What the force would be.
Go ahead.
What would the force be to keep the Kleenex from not breaking and the rock flying out?
All right, not only is the string carrying this force, you can say you yourself, depends how heavy the rock is, you yourself have to stand so that you won't get carried away from the rock from this force. So you yourself can be considered as the other force that Unorthodox was talking about. Not only the string, like you yourself have to keep this position and push against it or pull against it so you don't fly away. This is the force.
He's not talking about the fingertips of the string. He's talking about the rock itself having a force against the rock.
We were talking about the rope and the material of it. So
yes, the string is the one that holds it all together. It's the string. And we can see it's the string. We can logically assess it's the string. So there's no other need for a force when we know the string holds the rock. You understand?
We
are creating an energy is what we're doing.
Oh, wait.
Guys, this is as simple as it gets. I mean, this is as simple as it gets. Can I walk through a simple explanation of what I believe is happening and then you tell me what's wrong with it. Okay, so I'm gonna walk through an example, right?
Turn your thing off, man.
Excuse me?
You got echo going on.
No, not him. Oakley has echo. Or had echo.
Yeah, I shouldn't have echo.
It was Oakley. I think he dropped out, and I think the stream is.
Okay, so let me walk through my example. You have a sling, a rock in a sling. You're swinging it around, right? If there was no force pulling it towards you, the rock would be moving forward.
The string is there. Stop.
Okay, wait, just hold on real quick.
I mean, it's as simple as that, guys.
No. Unorthodox. You have to prove there's a force there now. You're asserting.
You can measure that. That's easily, you can feel it in your hand. You can feel the force in your hand.
This is the whole gravity, density, curvature, perspective argument. You are misinterpreting the data.
How so? You can feel the force. I'm misinterpreting.
Hold on, Flat Earth Data. Hold on, real quick. The reason why I'm saying you're misinterpreting the data is you are feeling pressure on your hand as you swing the sling. That is your data. What you're feeling is centrifugal force. You are misinterpreting that as centripetal force. You have to now prove that there is a centripetal force in order for you to justify what you're saying, and you can't because there is no gravity and there is no curvature.
I don't understand how you're relating this back to gravity and curvature. There's a centrifugal force. That's the rock's momentum, right? If you release the rock keeps going forward. That's the centrifugal force, is the rock's momentum. The centripetal force is the force that's preventing the rock from moving forward via the string.
It's the barrier that is, buddy, which you have, whatever the rock is sitting in. So if rock is attached to a string, the string is the barrier.
Yes, and it's transferring the force via the barrier.
Yes, it's transferring the weight of the rock, and the velocity of the spin is making an outwardly force to the rock. It's giving the rock, let's say, more weight, more inertia. Okay, we're driving that. We're not centripetal of that. We're creating a centrifugal force, and we're feeling the results of that due to the velocity of the spin. We can make it feel stronger, and we can make it feel it weaker by how fast we spin it. We have control over centrifugal force, creating inertia in that rock. That's exactly how a sling works. When you have a rock in a sling, you let it go and you release the rock. There is there's no inner force that's pushing back on the rock. You have a barrier. That's the sling arms and the sling sack. That's the barrier. That's it.
There's a force on the barrier, dude.
There's no force on the barrier. It's the material itself. Okay,
it's a solid. How come I can feel it in my hand?
It's a solid restraint, is what it is. It's a solid.
How come I can feel it in my hand?
We can observe it. So now, if you can demonstrate this force without a solid restraint, without a string, please do so. But we can demonstrate it with a solid restraint and prove to you that we're creating a centrifugal force by the velocity of the rock and how far we can throw it. Okay? So that's what we can do. We can repeat this experiment over and over again. We cannot repeat your experiment proving
yes, you can.
Word. Show me.
I mean, this is as basic as it gets. I could set something up in my kitchen.
You've said about basic about a million times. I've provided you with an example that anybody could do at home. Please do so.
It doesn't make any sense. Your counter argument
doesn't make any
doesn't
sense.
carry any weight.
We've heard that already. Please tell us what we can do at home to prove your point.
All you have to do is get a Lazy Susan that you can spin in a circle, and you'd have to have attached like a fish weight, right? That you weigh fish with, and then, or you could just do it with a fish weight, something that weighs fish. Tie a string onto the fish weight, or the fish scale, excuse me. Put an object on the end of it and swing it around. So what is your
restraint again? Your restraint is the measurement device. Your restraint is the string that's attached to the fish. That's what you have. Your restraint is that. Show me something that's going to prove without your restraint, without a physical obstacle restraint, because that's what you're showing us here.
In order to make a circular path, you have to have a restraint making it go in a circular path.
So you need a physical object to do it, right? So it's not a force, it's a physical object.
No.
Show us a force without a physical object, please. Because as far as I'm concerned, you need a physical object, which is called a barrier or restraint, to encapsulate the inertia caused by the revolutions of the spin.
Yes, exactly. You can't restrain it. You can't make an object move in a circular path without some kind of physical object restraining its movement. You can't do that. That's not how it works. I mean,
the restraint is
just
not
the fact
providing
alone,
the force, it's providing the resistance, it's providing the barrier. Okay?
The barrier carries the force.
Shout out to Michael Buck for the super chat. It says the only force there is centrifugal force. Totally agree.
If you let go of the rock, it would fly forward.
Show me an experiment with a force outwardly pushing against a rock without a restraint or a barrier. You can't. So why are you calling it a force when we know it's a barrier?
Oh my God. This is just ridiculous, guys.
No,
absolutely ridiculous.
This
is as basic and simple as it gets.
Show me a force without a barrier. We see the barrier. We see the physical barrier there. Why would I call that a force when I know it's a strap? It doesn't make sense. It's holding and resisting against an outwardly force is what it's doing.
The strap carries the force. I can't pull you towards me with air, with nothing. I need something physical to pull you towards me.
You need a restraint. So why are you calling the restraint a force?
Are you joking?
Why are you calling the restraint a force? It's
I'm not calling the restraint a force. I'm saying
yes, you are.
No, I'm not. It carries the force.
Sorry to
people here in the chat here, buddy. It's like so simple. You talk about being so simple. You can't even admit that the sling itself has a barrier, has a resistance. There's no force.
I admitted that. I mean, I'm not saying there's not a barrier. I'm saying the barrier is carrying the force. I mean,
it's carrying the outwardly inertia.
Absurd.
It's carrying the outwardly inertia created by the revolutions of the spin. You are making the spin. You're transferring the energy through the string outwardly, not inwardly. Nothing's pushing against you. It's pulling you outwardly. That's what centrifugal is all about, and that's what we can measure.
Equal and opposite. It's pulling you out. You're pulling it in, right? Every force has an equal and opposite reaction. It's pulling you out.
I'm spinning it. I'm revolving it, creating an outwardly inertia is what I'm doing.
There you go. There's your debunk right there. Every force has an equal and opposite reaction. You're spinning it around. It's pulling you out. You're pulling it back in. Equal and opposite forces. There you go.
It's the force of you spinning it. You're spinning
it.
That's the force. The opposite is the ball going around. The force is you. The opposite reaction is the ball spins. You're just inventing a third force. You put force in, the ball spins.
That doesn't make sense, Nathan. That makes zero sense.
The ball spinning is the reaction to you spinning it, you moron.
No, everyone on the panel but you understands this unorthodox. That's 9 to 1. 9 to 1.
With the hand wave dismissal.
You guys don't understand this because it's extremely simple.
Everybody in chat is saying that you're wrong as well.
Well, in this very moment, hold on really quick. In this very moment, I'm so glad that Arwin is not here because he would have been obfuscating and defending unorthodox.
He'd have been arguing for you.
I'm sitting here looking at the equations for centrifugal and centripetal force. And I don't even need to do that.
Equations are not the physical action.
They describe
Are you trying to relate this in any way to gravity and earth spinning?
No, I'm not trying to relate it to gravity or earth spin at all.
Okay.
That's what I'm saying. I don't understand why you guys have such a problem with something so simple. I'll say it one more time. It's pulling you out. You're pulling it back in. Equal and opposite forces.
Resistance. It's not pulling.
Equal and opposite.
The string is the barrier. The string is the resistance. That's what is keeping. Keeping it revolving. It's not you. All you're doing is giving it energy to spin. The string is keeping it revolving. The sack is holding the inertial energy. That's what it's doing. Barrier.
The torque
itself is not a force. It's a resistance. And the string itself is the delivery of the inertia. That's it. The string's distance gives you the revolutions. The longer the string, the longer the revolution. The shorter the string, the faster the revolution. So the string itself is the delivery device. You're just spinning it.
How does it not fly away if something's not pulling it back?
Restraint.
Because the stack.
The pocket is restraining it.
So the
Resistance.
pocket's pushing back on it?
Must have been said about 20 times by people in the chat as well. Resistance. Anyway, on that note, I think I'll say first and foremost a huge, massive, enormous thank you to all of the debating panel for making this debate possible. And of course, a massive thank you to all of the live audience for tuning in and hopefully sharing this debate. If you hated the show, you know exactly what to do, but if you liked it, maybe consider sharing it with a friend or subscribing if you've not done so already. I've been Nathan Oakley, and I will see you all in the next video.
Oh, what a day! What a lovely day!